morning, everyone. My name is Richard Bauker. I am from Peru. I am 20 years old. And I'm going to present my research paper titled Assessment of Blood Sound Reduction Using Retaining Walls in HUC AS. Here you can see today's outline. First, I will present my introduction of the problem. Then, I will describe the methodology we use. After that, I will show the result of both scenarios with retaining walls and without retaining walls. Followed by the calibration of the model, the comparative analysis, and finally the discussion and conclusions of the research paper. This slide shows Chosica, one of the most flood-prone districts along the Rimac River. As you can see, for example, these situations happened in 2017 because the river Rimac had this discharge of 120 meters cubic per second of cloud. And the bridge also fall down. So that's a big problem in Peru, and that's why I center my research paper in these situations. And this is why effective mitigation measures are urgently needed. Chosica Rimac River, highly vulnerable area to El Niño Costero. The geomorphology, steep slope, high population density in this flood race. The impacts, damage infrastructure, disruption of transport like this, and public safety threats. The methodology. Here is an overview in our methodology. We use a topographical data set from CIRGIT and hydrological data from CENAMI. CENAMI is an institution of Peru that recopiles a big discharge of every river that exists in Peru. I have hydrological data from 52 years of this river to analyze the situation and make a solution of this. The model was calibrated and tested under two scenarios without retaining walls and an intervention scenario with 1,200 meters of walls. And the validation was the comparison between simulated and observed by CENAMI. First of all, we analyzed the hydrological data. On the left, we have the instantaneous peak discharge measured at Chosica Station. As you can see, I have 52 years, but I only resume in this table. On the right, the graph shows the statistical methods, both method, Gumbel method, and HEP method, to analyze this instantaneous peak discharge measured at Chosica Station. As we can see, A gamble method has the more has more more stability of the other methods. These values defining the flows we later apply in the hydrodynamical model. And these are the values that we obtain of this statistical method of gamble. Now we have the results without retaining walls. These this map shows the baseline scenario without retaining walls. As you can see, it affected urban areas. And the simulation indicates that the flooded area was 2.83 hectares, have a maximum river level of 6.33 meters, and a maximum velocity of the river over 21.2 meters per second. And that's a lot. That have a bad impact in Peru. It's a big problem actually in my country. Now we have the result with the retaining walls, and the problem can solve, as you can see. We reduce the flooded area to 0.77 hectares. Now the maximum river level is 4.42 meters, and the maximum velocity of the river is now 10 meters per second. So we imply, for this, we had an implementation of protection structure of 1,200 meters long and 5 meter high retaining walls. Here you can see the calibration process. It's so necessary to calibrate the modeling because it shows that we are doing a real simulation, not a fantastic or unrealistic simulation. So first of all, we output data were selected from XRES2D and processed in Excel, as it shows. And the comparison between simulated and observed shares are represented in the section of Raymond Kramer. For this, we the shares calculation using the Teco rule. And finally, comparison with we did a comparison with observed with Sename data. So the simulated shares was 118.2 meters cubic per second, and observed shares by Senami was 120.3 meters cubic per second. So the determination coefficient of this simulation was 0.91 of this. Now we have a comparison of this analysis. As you can see, the contrast of results. In the initial situation without intervention, we didn't have a retaining wall, so the river level was 6.33 meters as a maximum peak. The flooded area was 2.83 hectares, and the river velocity was 21.2 meters per second. But now, with the situation with proposed solution that is using retaining walls, the river level down to 4.42 meters. The flooded area goes to 0.77 77 hectares. And now we implement 1,200 meters long and 5-meter height containment barriers implemented. And this reduced the river velocity too. So the reduction was 17% reduction of the river level, 72.79% reduction of the flooded area. The implementation was 100% of the retaining walls and 52.83% reduction of the river velocity, as you can see. Now the discussion analysis of results. The key findings is that, as you can see, significantly reducing the inundation extent. So if we apply this research paper in my country, we can solve this problem. We can avoid the first image, that is this. That's a person on there trying to keep alive. And also lower river stage preventing overstopping. Decreased flow velocities confirm structural things efficiency, and the application was resulting demonstrated effectiveness of retaining walls for urban planning and risk management. This research paper can be helpful to other researchers to analyze how was the impact of the economy in that situation. And takeaway model calibrated and validated because the efficiency was 0.91 and support reliability of proposed structure solution. So the conclusions. The effectiveness of retaining walls is so high because we achieved 72.8% in flooded area, 30.2% decrease in river stage, and 52.8 decrease in flow velocity. The research paper shows also model reliability because the calibration with tsunami data validates the accuracy of problems of the aircraft to the model. And also it has a good impact on urban and risk management. Lower water levels prevent overtopping, protecting vulnerable populations, and enhancing preventive infrastructure. And the future application is that some researchers can use this research paper to analyze more of this situation. And that's all.
Okay, thank you very much. A nice application on the AI tools, and if you have questions, we can get some questions on the application. Yes, please.
Thanks for your presentation. What about the data set? How did you collect all these data sets for 50 years?
Oh.
Is there any sensors, I don't know, or manual?
No, yeah, there's sensors. Tsunami is an institution in Peru that regulates this information for every day that happens. I have the data from tsunami. I needed to go to this office and did a card. They give me that information because it has a cost around $10,000. No, $10,000 if you don't use to a research.
What about the period of data collection? Like every day, every hour?
Every day and every hour. I have both.
Oh. So for 50 years?
No, for 52 years.
52 hours.
That's a lot.
Lots of
that.
data, yeah, lots of
Thanks.
data.
What about the cost aspect? Did you consider the cost of having walls since you're talking about having walls versus not, right?
Oh, the cost of retaining
Yes.
walls. That's a good question because I didn't emphasize the research paper to this, but it has a lot of costs.
Right.
I don't know how much, but if we analyze to a large time, it's better.
Yes, sure. I was considering maybe trade-off, like if there's a cost, how long it would take to remedy this cost. Like if it is 5 years, 6 years, maybe it's reasonable to do. But if it is maybe 100 years, a century, maybe it's not. So
Oh, in that case, El Niño phenomenon occurs every 4 years.
okay.
So the Peruvian government needs to do something to avoid that
Gotcha. Thank you.
So if an accident occurs, then that can have lots of problems.
Right.
If we compare the benefits, I mean.
Right. Yeah.
Nice. Any other questions? No? Okay, thank you very much. So I would like to give your certificate, Richie. Okay. So rest. Perfect. Thank you very much. Okay, so I would like to ask if our first and second talk presenters here. Oh, very good. So Dr. Baglan is here. You are Dr. Baglan? Or?
Yes.
Okay, so you are indeed session chairman. So you can
Take your role back.
yeah, you can take your role back. So maybe we can start with 36 and later 37. Yeah. Do you have your presentation with you? Maybe we can put there into
USB or something else?
Uh-huh. I think you have two presentations, isn't it? Or three? No, three I think, yeah. 67 also. Üç tane.
Can I say?
Please. First and second one, please.
These are.
The first one, please.
First one.
This is up down, and then the red one is the light laser.
Okay. Good morning, everyone. Welcome here in the conference. I am Ibar Samangirdi, and this is our research work on the smart buildings and smart environments. We came, three of us came from Kazakhstan just yesterday. It's very far, I don't know, more than 20 hours of flight and etc. Al-Farabi Kazakh National University, this is our main organization, and our company, Digitalim, we came from these organizations. Our theme is analyzing the impact of air quality and cognitive skills using machine learning in a smart building environment. So, this is the background of our research. We work on smart buildings, smart cities, air quality, ecology, and etc. And here in this research, we have made the indoor air pollution effects in cognitive health and performance. And the second is pollutions. We have a lot of parameters as a volatile organic compounds and particle meters. And the third is lab setups, and we have our system as a real-time data collection and sensor network. So this is the research question. It's an integrated system that combines the data collection model and the control of actuators, synchronized with cognitive testing and occupant comforts and cognitive abilities in different environments. So we have our smart building, smart environment, we developed it, and we have the cognitive tests, and we have set up of sensor network, and we collected all these data sets on the occupants and use it machine learning algorithms to explore the relationship between the environment setups and the cognitive performance. So yeah, this is our parameters, and cognitive performance, it's memory, attention, reasoning, coordination, and etc. So this is our data collection model. In here we have the home assistant and our sensors collection, and we have the server on this, and this is our actuators. We have the HVAC, heating, ventilation, and conditioning system, purifiers, ventilation system, all these models, and it's connected by wireless protocols. And we have the participants inside of our smart environment, and we have the reaction time, all these cognitive tests, short time visual memory, spatial perception, working memory, and etc. etc. So this is our methodology of data collection, volunteers, protocol 15, alcohol, no smoking before, and etc. Conditions neutral and elevated to conditions, and we monitor it automatically using these sensor networks, all the parameters of environment and also of our participants, reasoning, memory, attentions. So yeah, this is for our participants. Everything should be the same, like sleep, meal, taking meals, and etc. So we use it, machine learning approaches, different algorithms. After data collection, we use cognitive tasks. This is our results. Average reasoning level by temperature. We have different setups of temperature, and as you can see, average memory is increased in 30 Celsius rather than 22 Celsius. So in high temperature reasoning improved, and memory, coordination 5%, but attention slightly declined, decreased. So in here we have the distribution for the reasoning, coordination, memory, perceptions. As we noticed, median score for logic and coordination is higher here, and in greater individual variability, it's a wider spread. So this is for every participant. And here we have the temperature for reasoning for every participant. As we notice, someone affects also for individual temperature consistence of someone's, but mostly we have the like mean value in here, and for the perception also compared for the temperature and the memory, it's mainly the same part. And here we have the 1% in yellow, very different from the mean. This is our correlation analysis matrix. And in here, positive correlation of reasoning and coordination. Here, negative correlation is temperature of attention. Different our insights. So conclusion, we developed this smart environment, smart building, using sensor network, home assistant, our actuators, control loop, closed control loop system, and heating, ventilation, and conditioning system. And also, we we made different environments for all the participants, and we use it as an application using cognitive tasks for all the participants. So in here we have future works, future ideas that we are working on. After that, we are working in comfort of occupants and energy efficiency of all the smart building. As the energy efficiency, we created using a home assistant and sensor networks, different sensors. And on the higher level, except SCADA system, we have these three models: Energy Plus, Open Studio, and Synergy. And we want to make let's say, digital twin for modeling all the different situations of the walls, roof, all the actuators. This is the first case of working. And second, we are working on AI agents. We want to use AI agents for automatically adaptive control of all the environment, all the system for the comfort and energy efficiency. We are using now NVIDIA Jetson Orin. It supports small language models, and we created, trained, fine-tuned Llama 4D, use it retrieve augmented generation, vector database, quadrant, and now we are implementing embedding Gemma inside of that. So we want to add this AI agent inside of this smart environment to collect the data, analyze the data, and control all the actuators. So we have collected for a lot of years data set from all the environments, and we want to use fine-tuning methods and RAG methods for these small language models on the edge side of our device, and NVIDIA Jetson Orin as a AI agent for this environment. And we are trying to create a digital twin because in here we tested all these things on the physical environment. Now we want to use digital twin environments, and because we are also focused on deep reinforcement learning. As you know, here we need a lot of cases, a lot of data set for our agent, so we can try in different scenarios. Because of that, we need a digital twin, let's say some open gym inside of environment, so they can learn all the. And after that, we are planning to go after AI agents into the physical AI and embodied AI. This is like future ideas, and we are also thinking about it. So, yeah, this is our future works and ongoing works. If you have any ideas to share about it, we are open to discuss and to upgrade it, make some modifications. So thank you for your attention.
So thank you very much. Questions? Yes, please.
Yeah, so since portfolio your work is energy efficient stuff like, did you measure how much energy you will be consuming using the Jetson? Because like Jetson has GPUs and it consumes like a significant amount of power. And there are a couple of accelerators you can use, like they consume less power than the Jetson. So have you went through this?
Thank you for your question. This is our our one paper for energy efficiency. We have RTX 6000 Pro. It has 96 gigabyte of VRAM. We implement their Llama 70B, and we have NVIDIA Jetson Orin. Inside of that, we have the small language models, and also we have Raspberry Pi with AI Hat on. I remember the chip, and also Intel Neural Stick, Google Coral Dev Board, Google Coral USB accelerator. Yes, all of these, and we are measuring, as you said, the energy efficiency of different architectures, TPUs, NPUs, GPUs, on all the SLM and LLMs. And this is our new paper coming.
So you end up with JITSON, or like, is there any difference in the accuracy between all of them, or
Sorry?
like regarding the accuracy of these accelerators? Have you noticed any difference in the accuracy? Like
For now, it's like a speed of computing. Yes, time speed of computing nowadays, but accuracy we don't notice like much. But the tokens per second, it differentiates because 6,000 and let's say I don't know Raspberry Pi with AI, it's like 100 times.
Yeah. Thank you. Great job. Thank you.
Yes, please.
How do you think about 10 volunteers is enough or not for data collection?
Sorry. Could you repeat?
You mean 10 volunteers
Yeah, yeah.
use
Yeah,
usually?
yeah. In this, our developers created this system. In team, we have like 10, 30 researchers, and they developed it after we asked them to participate in this test. So developers participated in this experiment. So we can see the comfort, energy efficiency, cognitive performance of researchers.
Yes, please.
Just to follow up this question, for statistical significance, it's very important to have enough number of samples. That's point one. And point two, maybe you have answered, just I'm asking.
Yeah.
Point two is for human perception, age plays a key role, and gender. Not that you get offended, but that's our nature, by nature. So how did you address these two questions?
Okay. About the male, we unfortunately we didn't consider it, but we should add it, as you said. Thank you. Maybe in the future we will add this one more feature as a male, female. About the age distribution, yeah, we have this situation in another work. We have this problem about the age distribution difference, and in here, our AI developers mostly they are like not so old, like 25 years old. Because of that, our age distribution is like very in a low level. We should consider it, yeah. Like we should add in other research paper we invited elderly people from elderly house to participate in our experiments, but unfortunately in exactly this research paper we couldn't invite them to participate because of movement stability. They couldn't come to our smart environment. We will consider it.
Yes, please.
What is the scale of your data? Like, can you give us idea? Is it very big, or
I think
also
it's 10,000.
the linearity of it? Is it spreadsheet data, tabular data, or it's very nonlinear? I mean, your features for machine learning, are they of the same type? Yeah, a little bit information about the scale and the type of your data.
It's about, we have with non-participants just environment data for more than a year, about more than 1 million samples, I think, about, I don't remember, 25 features.
25?
Yes, and we added our participants' data. It's cognitive tasks. It's less, I don't remember the exact, but it's features about 7, 8, and the samples like 200. It's a less. Yeah. So.
And it's tabular, I guess, right?
Tabular data. Yeah.
Any other questions? Yes, please.
You have mentioned about different kind of sensors. So in case of BOC, what sensors did you use?
Sorry, BLC?
BOC, the volatile organic compounds.
Yeah.
What sensors were used for that?
For echo monitoring, we have in the first version we use DF robots, and in the second version it's a Winsen ZH10B. It has 11 sensors: ozone, formaldehyde, CO, CO2, NO, NO2, PM2.5, PM1, PM10, volatile organic compounds also. I think it's not EVOC, not, yes, it's like just straight VOC. It's Vincent sensors mostly. I think laser, like optical sensors, not thermochemical sensors that hits, it's optical one.
It's Vincent, V-I-N-C-E-N.
Yes, W-I-N-S-E-N.
Other questions? No? Okay, thank you very much.
Thank you.
So this is for this your certificate.
Thank you.
Maybe you will have other talks also.
Yeah, yeah.
By the way, I would like to make a reminder, on the door, you will see some QR codes. I mean, these are for our 2 other conferences also, with this one, so 3 conferences. So you, there, when you go into the QR link, you will see, you know, a form that you can, it's a kind of enquete. So you can have some questions and you can have some answers, just only 5 questions. It is very important for us to improve our conference, the quality of our conference. Please, just with a QR code, you can share your you know, suggestions, comments with us to improve the conference. Thank you very much. Thank you. So, we have a 36 assessment of the impact of air quality on rehabilitation effectiveness using an IOMT-based HRV monitoring system. By Zanen Bagareyeva here.
Sorry, can I share with my presentation? It will be 38.
30.
Number. Yeah, it's in flash disk also.
37, sorry.
37, yes, yeah. But what about 36? 36 is yours or?
Yeah, I will.
Okay, later on, okay.
Yes, next.
So please. Is this, do you have the presentation
Yes,
right?
so-
Ah, okay, this one. Your name is?
My name
Please
is-
introduce
Yeah,
yourself
yeah, yeah.
briefly, please.
Good morning, dear participants. My name is Nodole Tasmusaev. I came from Satellite University from Kazakhstan. My topic is IoT-based intelligent real-time air quality monitoring system. I am going to share with you my presentation. In our country, I am from Almaty city, and Almaty city, it's in Almaty city near a lot of mountains, and because of that, high traffic and near mountains. Because of that, our city is in top 10 of air pollutions in the world, and because of that, that topic is interested me, and in the world every year 7 million people death from sickness and other features seems to air quality, and our proposed solution is an IoT-based monitoring system built on ESP32, integrates cloud analytics and machine learning, and it tracks important features of air. It's PM2.5, NO2, and the CO2, and the other pollutions. And algorithms and value. The ML core, our random forest model, it shows us 89% of accuracy. And
Problem statement. Air pollution is a critical issue, contributing to increased mortality. The World Health Organization estimates its impact at 7 million deaths per year. And the drivers of pollution growth, it's urbanization, industrialization, it's making higher of PM2.5, CO, and NO2, and in urban areas, in the big cities. And the limitation of traditional approaches, it's sparse monitoring stations and the manual sampling provide slow and fragmented insights, and it should be real time, and urgently give us analytics per time. And our purpose is IoT and ML introducing. Modular IoT nodes detects pollution's hotspots in real time, and it's give us analytics and give us predictions with ML. And in Kazakhstan case study, we offered to use it in Almaty. And Almaty in winters we have very high level of pollution, air pollutions. And in Astana, CHP emissions drive long-term trends with winter PM10 and NO2 peaks. And our research focus is sensor ML integration for real-time CO classification and enabling timely interventions. It's our architecture. We are collecting data from sensors with ESP32 and send it with via Wi-Fi to our API to our local server, to our cloud server, and our parameters is CO2, CO, CH20, NO2, volatile organic compounds, PM and the PM10, and also temperature and humidity, because in our case we noticed PM10 and other volatile organic compounds, it seems different when humidity is changing. Yeah, and it's our device. Here you can see NQ sensor and the PM10 and the PM2.5 sensor and our ESP32, DHT22, and our board. Yeah. And after our data collection, we introduce here ML visualization, and you can see here our correlation matrix. After our correlation matrix, we notice which parameters most affect to other parameters. And you can see here, for example, we notice it NO more affects on PM particles also, and the humidity also more affects on volatile organic compounds. And our results, model performance. Here, confusion matrix, low CO detected with very high accuracy. It demonstrates as strong model sensitivity to safe low levels. And in medium CO, partial confusion with high class, it reflects overlap in concentration thresholds. And high CO, most difficult boundary, it's however misclassification occurs only to neighboring categories. And in conclusion, I want to say system and practical value. It's end-to-end IoT platform, sensors, cloud, analytics, visualization for air pollution parameters, and the modular architecture scales from cities to industrial zones and indoor spaces. Real-time data plus ML, it's early warnings and the decision support. In the future works,
we are planning, it's that data collected in small area in the city, and we are, our future works, we want to apply it in the a lot of parts of the city, and analyze which factors most impact to air pollution. It's our target is heating, heating water buildings and other factories. And after that, we are planning to create a platform. And in this platform, you can see most important factors to air pollution. Yeah, and we want to apply also drones and using grids, crowdsourcing, and satellites to more make impact. Yeah. Thank you very much.
Yes, please.
Questions?
Yes, please.
It's very interesting work. Could you please elaborate about your sensors accuracy and sampling rate?
Yeah, we unfortunately I didn't add here about we tested with Xiaomi IQ Xiaomi with Xiaomi air quality devices, and it's show us very near data collection, and accuracy was near to 90, 82, 85%. Unfortunately, I didn't add here. Actually, we have paper with that work.
And data sampling rate for different sensors. What was the data sampling frequency?
Data sampling frequency. Sorry, can you ask the question more detailed?
For instance, you have a CO2, right? And also
Yeah.
some, I see over there a particle matter, also NO2, or
Yeah.
some other things like temperature, relative humidity, etc. How often you pick up the data from your sensor? What was the time interval between data points?
Okay,
Every
okay.
minute,
Now
every
it's-
second, or every day?
Okay,
what?
okay. Because we collect the data every 5 minutes with the sensor, and we use it Wi-Fi, and we collect the data. For example, we install our device on the window outside, and via Wi-Fi we collect each 5 minutes data. Yeah.
Thank you.
Any questions?
Yeah, maybe I can ask about the deployments. Thank you for the presentation, nice one. Since you say end-to-end, did you develop a pipeline or did you use a ready pipeline, frameworks, that just does end-to-end?
Okay.
Analysis.
We created our pipeline, but we have a lot more close to similar works. But we tested that ML models with other ML models, and it shows us good accuracy. And here, it's our own software, and we designed that board with ourselves. It's totally our own device.
Yeah, that's great. Which machine learning algorithm?
Random forest.
Random forest.
Yeah. Random forest. It show us, I guess.
But have you also tried other tools, only random?
Yeah, we tested it with LSTM models also, and with XGBoost model, and random forest in this case show us better accuracy.
That's interesting. I was going to say XGBoost is the
In
standard,
fact,
right?
Yes,
I mean,
in
it usually
now
gives
it's,
better
XGBoost,
performance.
It's in our favorite one. In other projects with medical data, XGBoost show us best accuracy. But in this case, Random Forest show us better one.
That's great.
Yes, please.
When you tested LSTM, were you able to deploy it in ESP32? Is it deployable in ESP32?
Sorry.
Were you able to deploy LSTM model? You said like you tested LSTM.
Yeah.
You can deploy it in ESP32?
No, actually, because in ESP32 we use it only to collect and send our data. Our ML it's situated in our server, our cloud server.
Okay.
Yeah, it's not edge.
Yeah, it's not running on the edge. Yeah.
Yeah.
Yeah, I thought it was actually.
Other question? Okay.
Thank you for
very
your
much.
questions. It's
For
very
your
important.
presentation. Here, press is important.
Thank you very much.
Congratulations.
Thank you.
One more. Yes. So, also greetings to Almaty, because he said about the air pollution, but I know that I have been a few times in Almaty. Almaty is a very clean city indeed, but they are really very well interested in the city to make much more cleaner. So that work is for this. I mean, Almaty, I offer all of you, you must go, you must see this city. And there's a very good mountain very
Yes,
nearby
very
the city,
nice.
Chimbula, isn't it?
Chimbula Mountain
Yeah.
Resort, yes.
Everyone should really test to go there, and then it's very good skill. I mean,
Thank you. Thank you.
Okay. So I think 36, isn't it? This
Yes.
ID 36.
Yes, yes.
At the last, so we have assessment of the impact of air quality on rehabilitation effectiveness using an IOMT-based HRV monitoring system. Please.
Good morning, everyone. Nice to see you. This is our another research work with Dr. Jamil and our professors. The team's assessment of the impact of air quality on rehabilitation effectiveness using IOMT and HRV. So, as you noticed, we have the background of eco monitoring, the data collection of ecological parameters on the energy efficiency, and also in here we have used IOMT, Internet of Things, Internet of Medical Things, ECG and PPG devices for data collection. We have introduced one more feature as a heart rate variability, and we want to see the effect of ecological parameters because of our city and etc. Ecological parameters into our physiological parameters. Ecological parameters and physiological parameters as a heart rate variability. Because heart rate variability is an important biomarker of the autonomic nervous system. We have the central nervous system and autonomous nervous system. And inside of autonomic nervous system, we have the sympathetic and parasympathetic nervous system. And we measure all these systems, nervous systems, with ECG or with PPG, photoplethysmography. And here, we also made an experiment with our volunteers, with our research engineers also. And we collected ecological parameters, all these parameters, PM, ML, VOC, etc. And also heart rate variability metrics. And a lot of functions. So in here, as I said before, physiological indicator, because we want to see how it progress, because cardiovascular diseases. It's the #1 diseases in the world, according to World Health Organization. And cardiovascular diseases we can measure by heart rate variability. Inside of heart rate variability metrics, we have RMSSD, SDNN metrics. So we measure all these metrics using PPG, photoplasmography. And then here we have the genetics, lifestyle of all our participants, air pollutions, age. This is ecological parameters. And then here we have the real-time data collection, database, and all the IoT and IoT sensors. Here we have the methodology. And here, as we said before, this is the Wilson sensor. So as you can see here, we have like 11 sensors, and we connected it to the Raspberry Pi 5 using UART. So we sent it to our cloud server, all the ecological parameters. And here we have the IoT device with photoplasmography to collect on our finger heart rate variability parameters, and also heart rate, etc. So then here, as you can see, this is our architecture. This is ecological sensors, Raspberry parameters, and then here we have IoT device. We call this Jurek IoT device. This is the parameters, heart rate, and RR intervals. We also collect these RR intervals on photoplasmography, SDNN and RMSSD. And after we make the correlation matrix, all the effects between all the parameters, how affects, let's say, particle meters on our autonomous nervous system. And this is our algorithms, NN, GBoost, all these algorithms. Architecture, data acquisition from the wearable device and environmental. And we have the MQTT, HTTP, post requests, APIs, and etc. UART for data collection, synchronization. On the back end, we have the feature extraction from our photoplasmography into RR intervals, after RR intervals into HRD metrics as RMSSD and SDNN. And then here we have the machine learning algorithms for risk analytics of cardiovascular diseases. And so in here we have the results. We use 3 locations. First, it's our university, Al-Farabi Kazakh National University, and the second, it's the biggest highway, Al-Farabi Avenue. And the third one, it's near our university, it's Botanical Garden. Yeah. So this is the findings. We noticed, this is the key finding. PM2.5 was strongly correlated with decreasing of SDNN and RMSSD, main metrics of heart rate variability, because indicating autonomic stress. So PM2.5, these particle meters inside of this air, it affects to our autonomic nervous system. So this, and CO2, it's negative. It's had only minimal effects on heart rate variability. So this is the conditions of relative humidity. This is the heart rate. It's not respiration rate. It's RR intervals. Yeah. This is the SDNN and RMSSD mean values in milliseconds. So in here, as you can see, we have the correlation matrix and air quality. In Botanical Garden, we have this was very interesting key finding for us, that in Botanical Garden we had the highest PM2.5 rather than on the highway. This caused because of humidity traps particles, because in Botanical Garden there is a lot of trees, and because of a lot of trees we have very high humidity, and because of very high humidity we have humidity traps for particles, and these particles affected our autonomous nervous system. Yeah. So in laboratory, because we have the HVAC and these air purifiers, but we have a lot of researchers, and so because of that we had a very high CO2, yeah, but it has an effect to HRV biomarker, but maybe it will affect for the different biomarker, but in our case of this study it hasn't affected. And on the streets also we have the noise levels and etc. But the effect of PM2.5 more than noise and etc. So HRV correlations, PM2.5 lowers SDMN and RMSSD. This is we can call it this HRV as a physiological stress. This is not emotional stress. Emotional stress is in our future work. So yeah, PM is weaker and CO2 minimal effects. And yeah, in correlation matrix you can see all these features. So conclusion, air quality, especially PM2.5 significantly reduces HRV, RMSSD, SDMN, and we want to use this in we are using in rehabilitation after knee operations of elderly people for the long term, and the future work we are using on the elderly houses using this age distribution, make diverse groups, and also seasonal studies like winter, autumn, all the four seasons. And rehabilitation process, and we want to use this EMG devices, more features to see new features interaction that will affect to our nervous system. So this is our future works, and also we have another work in there. We are assessing stress with HRV metrics for the cardiovascular diseases. This is also our future work. So thank you for your attention.
Questions? Yes, please.
This is really remarkable work. One point really took my attention is how come this CO2 influence on heart rate variability is so minimal? That's really interesting. Can you elaborate on that one?
Yeah. We previously, before this experiment, we thought also like that, because let's say in here ventilation is not working properly and our it's very high CO2, let's say, I don't know, 2000 ppms. We have some little bit headache, etc. As we notice here, maybe it will be not physiological stress of the HRV, because let's say this is my smartwatch PPG, and we collect this HRV metrics, but in here it hasn't affected. CO2 hasn't affected that. Maybe it affected by the, let's say, the age distribution, because our researchers, they are mostly young generation, maybe because of that. But in this study, PM2.5 particles affected mostly.
Good catch.
I play tennis because of the reaction.
You're sharp. So anyway, how long you collect the data? Maybe it's a history of data would make a difference.
There is a standard of the HRV metric this standard is like a world standard of assessing HIV. It needs 5 minutes at least. So according to the standard, so 5-minute data collection of PPG, it's one sample of HIV metric. So yeah, we have some samples of HIV metric. After that,
Makes sense.
So, question? Yes.
Did you compare your system with state-of-the-art smartwatch measurings?
yeah. Here we have, yeah, it's also interesting. We made this review. As we noticed, we developed, we wanted to use previously the smartwatches, Apple, Samsung, etc., but they don't collect HRV metrics. We noticed that they collect HRV only when we sleep. SpO2 saturation, oxygen saturation, and HRV only when we sleep. I don't know because of, is it because of FDA standards or something? But when we are going, it measures just HR. So we use it external softwares. If you use external software as a HRV for training,
HRV logger.
HRV logger, and etc., it costs money. They have their own algorithms for measuring this RMSS DNM, like data fusion and etc. It collects in real time, but in here they don't collect, unfortunately.
For
So
your-
because of that, we developed our own using these Max DF robot sensors, Raspberry ESP for real
That's
time
great,
data
that's
collection.
great. Was it XGBoost winner in your case? Which machine learning algorithm was best in prediction?
I think XGBoost, yeah.
XGBoost.
Here, XGBoost, almost in all our researchers, XGBoost is
Winner,
is
yeah.
winner.
Other question?
And one more thing, there is another smartwatch like Whoop, I think it's Whoop.
Whoop, yeah.
Whoop, but it costs $200, I think.
Right, and they have subscription. I think.
Subscriptional, and yeah, maybe because they have FDA approval for the algorithm, and because of that they sell it for $200. So please, Whoop, $200. But in Apple you don't pay subscriptions, but they don't have in real time, and this is also an advantage here. And now they have some patent problems of the these algorithms because they took it from someone, and I think in Apple Watch 10 they have some problems in patents.
Right.
Okay, thank you very much.
Thank you.
So, actually, this is a cooperational work also. I can also get Baglan here, so we
Professor.
can make, Professor,
Please.
together.
Ah,
You too, yes. So, yeah. So since she has a sore throat, therefore.
Actually, that slides.
Like this,
Maybe here.
it's okay. Yeah. But anyway, we are very bright, personality, so it will not happen, I think. Okay, thank you. Thanks. So, now, I think the stage is for 57, exposing the security vulnerabilities of generative AI, a comprehensive survey from Anuha or Anuya?
Anuja.
Anuja?
Yeah.
Ah, okay. Because in some languages, this dot is sometimes Y, sometimes in Portugal or Spanish languages, it is H, like H. I mean the pronunciation says. Okay. So, Anuja, please introduce yourself shortly, and then, yeah, you can present your work.
Hello everyone, good morning. I am Anuja Sawan from California State University, Long Beach. I am a grad student pursuing Masters in Computer Science, and I am with my teammate Raj Kandur. We have done research on exposing security vulnerabilities of generative AI, a comprehensive survey under the guidance of our Professor Abdul Basit of the Department of rapidly increasing. Like nowadays we are using ChatGPT, Claude, Gemini, and multiple other image and video models. So it has benefits like it is offering automation, personalization, creativity, and enhanced interactions between us and technology. Along with that, it also has risks like privacy, biases, adversarial manipulation, and jailbreaks. So our goal is to highlight these vulnerabilities, and we need to understand these vulnerabilities urgently and for the safety and the fair use of generative AI. So since it is increasing overall, so mostly it is increasing in critical domains like business, healthcare, and finance, and other creative fields. So security, privacy, and ethical risks are pressing concerns, so we need to address them. So there are safeguards like guardrails and filters, but they are insufficient and they do not always protect against all the threats. And so there is between the capabilities of the AI and the risk awareness, there's a big gap between that. So we need to bridge that, and bridging the gap is very essential right now. So there are models that generate novel text, images, and audio or code generation like GitHub Copilot. So there are also architectures like GAN, which is basically general adversarial network, which is an ML model which generates code for representation, and transformers like GPT, ChatGPT, and they are trained on large-scale web scrap data. So that's why it is vulnerable to privacy and bias. Like when there's a lot of data, there is privacy and bias issue. So also cloud API deployment models, they work on cloud and API service. So that's why there is an additional attack surface vulnerable to that. So why this matters now, why it is important to discuss about it today. So since it is used in critical domains like business and healthcare, etc., so the usage is increasing day by day, and we cannot control it. We cannot stop it right now. It will be increasing moving ahead. So like guardrails and filters. Guardrails is basically a protocol and a safety feature to protect against all the threats happening before. And filters is like filtering certain type of websites. Like this is blacklisted, like this is bad or this is good. So they are necessary, but they are not sufficient to protect against every threat we have. And cloud APIs introduce infrastructure and data in transit risk. That's what I said earlier. So our goal is like to create a safe and fair deployment and accountable deployment which protects against those risks. So our research basically focuses on four of these research questions, which security vulnerabilities matter most in practice, and how are they exploited in the wild, which mitigation actually reduce risk today, and what legal and ethical complexities must be planned for. So these are the key vulnerabilities we found while researching. So jailbreaks and guardrail bypass. Basically, jailbreak is like breaking in jail, which is basically what it means. So it is like giving prompts, multiple prompts to the AI, and like tricking the AI to do something else which is not trained to do. And guardrails is basically protected. So when the jailbreaks happen, this it bypasses that guardrail, it doesn't obey to that guardrail. So basically that is a vulnerability. It becomes vulnerable to any type of threat. Then malicious code generation and backdoors is like LLM model becomes like it is programmed to create a malicious code. So it will generate a malicious code, and like it will create it will generate a malicious code which is not programmed. It is initially programmed to do that. So then model inversion is like AI models continuously so that it becomes like it infers a different type of data, what is not initially like it is made for. And membership inference is like the sensitive data is like vulnerable. Sensitive data like personal information, secure social security numbers, names and addresses. Like they become vulnerable to like viruses and everything. So like they become open to attackers and scammers. Then man in the middle attack on API traffic is like some malicious party is coming, third party is coming between the communication between the API and the data. So it interferes in between that, and it interferes between that, and either it will be like it will monitor how the AI model is working, or it will manipulate it. So like wherever the AI, mostly the AI servers are like on AI is developed on external servers. So if there is no protection provided to that AI server, those become vulnerable to this management. Data poisoning is like this happens during the training of the AI models. Like when we are training the AI models during the time, suppose there are some flaws introduced initially only, so it becomes like it sabotages itself and it becomes vulnerable to attacks. And then adversarial inputs is like fooling the AI. Like suppose it is programmed to do something, and providing adversarial inputs is like it will do something else. Like if it is given a stop sign is designed as green sign, so it won't stop. It will go ahead, something like that. And we have compared this vulnerabilities and like how they can be mitigated. As I explained, jailbreaking is prompt engineering and bypassing logic. So DA in prompt is like DA is basically do anything wrong. So it will override the AI. It will tell the AI that do something right now rather than what it is already doing. So I don't know, like mitigation is like what we can do to secure it. Adversarial taking basically means like the model should be already informed regarding all the like suspected attacks it will be having. So we can use that to mitigate jailbreaking. Then malicious code generation, for that we can use output filters and audit logs. Like output filters, like what type of output the code is generating, like whether it is malicious code or it is normal code, whatever it was initially designed for. And audit log is like we'll track the events, activities, whatever is happening, so that we can go back and see whether some like bad activity is happening. And then model inversion, we can do for differential privacy. For mitigating it, we can do differential privacy, like we can hide the sensitive data, and if it is not open, like it is not susceptible to threats. Then for management attack, we can introduce TLS encryption, like an encryption between the client and the server side, so that it doesn't, no third party can interfere in between. Then for data poisoning, we can do provenance tracking, so that we can we can handle the data sets better. And then for adversarial inputs, same technique which we can use for training, adversarial training, like we can train the model initially only regarding the adversarial attacks. So rest of the slides will be discussed by my team later on. Over to you.
Yeah. Okay. So thank you so much, Anuja, for discussing all of the basics about generative AI. And we all know like generative AI is the one, like most common is ChatGPT. We use it for creating images, text, or the code as well. Most of the companies also rely on ChatGPT, like for creating the AI content or any software code. It is way too widely used right now, but also we have to make sure like how secure it is. We are using our own company's data, so how much secure it is. So some of the real world examples like which has caused trouble with the help of the by using the generative AI. So there was one incident for airline refund jailbreak, which was Canada's airline, in which the customer tricked the AI, and from which he asked for the refund to the AI bot. And what exactly happened is like the bot was tricked and hacked completely. So the customer was not having any refund, but the AI promised the customer that he will give the refund to them. So as per the court official rules, the company was forced to honor because it was the promise from the AI bot, and the whatever the refund was there, it has to be provided. Also, there is one more like Trojan puzzle. Some of the AI models which we are currently using have some kind of backdoors, or we can say a Trojan, where the hacker can easily access and create the program as per his needs. Like he can convert the whole code and change the things, and let the AI do the harmful things which can be cause damage to someone or some information. So this is way too dangerous. Also, we discussed all about the risk and all. So data leakage and risk inputs and training. So as I discussed, there are too many data leaks, privacy issues from the users input or the companies or anything else. So we have to overcome this. Then personally identifiable information, like someone is sharing personal information, then emails, then company names, or the code which is used to be having the customer's information for the company. So all those information are on high risk if we are sharing this with the artificial intelligence or the AI bots. Also, IP authorship and mimicry. So recently, one of my friends who is music creator, he just uses his own creativity, own models. But recently, he started using ChatGPT because ChatGPT is also helps to create the music and some kind of basic edits. So he used that model, and he created his own music. And while he was publishing, he got the copyright issue. Like he didn't publish it at all. He just took the help of the AI models, but he still got the copyright issue. So it also has the authorship, like our authorship can be publicly used. Then compliance and policy gaps. So I don't think any government policy is there to handle this kind of uh, problems. Like the incident I discussed about the Air Canada. So in this, there was no specific rule by the government. So company was forced to do what the bot has done the mistake. Also, bias in generation. So if we create some kind of model, suppose the model is related to finance and we didn't provide any information related to auditing, and we have less information, and some users are experiencing some questions related to audit things, and this does not have the information. So the less information means less performance. So we have to make the generative AI model according to the performance. Like we have to input more and more data so that it can perform well. And learning and repetitive societal biases. So as I said, like all the models will, how it will take the data. So it is not the developer's thing. Like developer will create the model, but he will not import its own data. So all the data are taken by the user input or the internet. So it is not at all the safe thing, and also it will start repeating by the human biases. And black box complexity audits. So right now I don't think it focuses more on the audits because we don't know how the decisions are taken by the AI. So it is not still more focused on the audits. Data set curation, post-training filters. So these kinds of filters help to reduce the security, like the risk, but it is still not enough right now. So mitigations. We have plenty of mitigations to reduce these things, like encryption thing. Then we can put some privacy policy, like limiting the data. Like we have the company's code. So we should do the 70% work on our own, and we should take the help of AI, which can be like 30%. Use of AI is best anyways. Like whole project can 100% be made with the help of AI, but it has the plenty of risk. We don't know how much the data is publicly used or must be leaked or what. That's why we should not depend more on the AI model. We should work on our own, and we should take help as much it is needed. Also the block and tracing, so output filtering and audit logging, we should trace all the data which we are providing. Also we should trace like how the information is gained with the AI model. Suppose we have the content related to healthcare, we should see like how much data it is taking from the internet and how much we should trust on this. We should maintain the trace and track it. So what actually works? So until now we got to know there are too many risks, and what should we do in these cases? Like there are mitigations which will reduce it, but it is not still enough. So we just can't rely on the single technique. We should get like more and more layered things, like multiple techniques, such as encryption is one of the things. Then we talked about the information which we are providing. Like multiple layers of security will make it more secure. And also jailbreak testing. So jailbreak is nothing but bypassing the rules. So AI can be bypassed because we have some trojans or hidden spots in AI. So it can be bypassed. So we should continuously test these things. With the help of, we can predict what can be the actual cause if we implement this kind of model. So previously if we do the testings on this, it will be more helpful. Like our data will be more safe in this scenario. Also least privilege, like try to give as much low as the data to the AI, so that if we give more data to the AI, it is obviously it will spread the data into the public, because AI learns through the user inputs. So as much data we provide to AI, as much data is spread in the public. So try to give less data. Then sandbox code execution, then monitoring for drift, leakage and analysis. So again we have to maintain the track, how our data is going to spread and how we should monitor it. We have to maintain the regular testing. We have to trace our data. Then also we have to bypass, and also we have to provide less information. So recommendations, it's all the same again, I'll repeat. Like we should use less data and more focus on the tracing the data and giving them less privacy. So sit with the threat model and abuse cases, instrument for observatory from day one. Like if we are creating one model, from the day one we should observe what process we are following and are we facing any kind of issues. Before creating or before using the model, we should predict what can be the damages to our system, or what can be damage we can get, like what kind of attacks we can get. Then future directions, AI for AI security. Like we can use AI for AI security as well, for the testing purposes or for the prediction of the attacks. We can use AI models. Like we can ask AI what can be the causes which if we use such kind of model, what can be the attacks. If we predict all those attacks, we can work on it, we can maintain track of it, and we can maintain our data more secure. Then stronger governance and enforcement frameworks. So also we have those frameworks, and we can take the information and legal advice, so that we can get to know about more information security. That's it. Any questions for this?
Questions?
Thank you.
I can ask.
Yes.
With all these action items and the hiccups with the generative AI, isn't industry standard I mean, we have industry standard, like Microsoft guarantees that if you're using ChatGPT API, you know, through their servers, it's kind of industry standard, right? I mean, are these what you're saying at the top of these standards, or if these standards are not applied?
Like most of the ways it is applied, but it has said like all the AI bots are learning through the user inputs or from the used data which is provided on the internet. So our data is not that much secured, so we can't say like how much security is provided. Like it's still learning, and if any incident calls, like recently there was one incident, I'm not much sure about it, but there was some incident like the ChatGPT data has been leaked. I'm not sure if it is accurate or not, but if such kind of incidents happens in future, so there is no chance, like if we are providing more data in this, it can be leaked at any point. So it is not that much secure until now.
Okay.
Other question? Yes, please.
What about these local US law according to the log files, logging of all the chats and etc.?
I don't think there are like any confidential laws right now for protecting for handling this AI thing. For that Air Canada's incident, there was no law, so just the government just forced the company to pay the difference because it was the promise from their end, it was the mistake from their end, so they have to solve it. But as we see, it was the mistake and it was the issue like hacking thing. So there should be a proper law, but there is no currently any law. Government is not enough able to handle this kind of things right now.
What about log files? I think it's a mandatory to save all the log files.
Are you thinking about audit logs and so like tracking every prompt? Are you suggesting?
All the history,
Okay.
everything on the market.
Yeah, that's a very nice suggestion, so we can implement them in the future. But I don't think it's right now in large scale, so it's not that strong. So what you said that we need to enforce a strong laws, some like tracking, we can input, we can like implement audit logs for that preventing the attacks, but it's not on a large scale. That's why attacks like on Air Canada and other servers like make the companies vulnerable to AI model, adapting to AI model in large scale.
Like we still don't know like how that AI is taking the decisions. It's just taking the user inputs and data sets from the internet, and how it is actually taking the decision we still don't know. So can't say about that law.
I think it's mostly about explainable AI, how it works. What about AI roadmap of US? Is this implementing nowadays in all this your research? I think
Not
Trump
for-
made some AI roadmap in here.
Our research doesn't include that, but thank you for that. We'll move ahead and our future actions will be included.
I think there are too many things going on to protect the data from the AI, and also different companies are trying to create their own models and trying to import their own security. So it's still not 100% sure. It's on user like how we have to make it more secure, how much data we should provide it to the model.
I have one question. How you think about federated learning?
Sorry?
How you think about federated learning? I'm not specialist in this area, maybe it's not in area, but some now federated learning they use for like a local learning of machine learning models for like for safety of data moving, how to say, or that data sending.
Can we use federated learning for LLMs, like without sharing the data, just sharing the weights?
Yeah, that can be used. We right now we haven't researched on that, but
that can be used.
What about proprietary and open source LLMs? Which one is considered in your research?
Open source.
Closed to it or open source?
Proprietor is like it is for open like stakeholders and companies. So this is more like an open source model, which is vulnerable to everyone.
We have one idea, like we are trying to make a project on this, like creating the own healthcare model, so that we can provide the security and we will predict like how much security it should be and what type of security we can provide on this.
Okay. So, thank you very much for your, maybe you can come here.
Yeah.
So, this is right, and this is Anya. So, we can make a good picture. Good.
Thank you so
Thank you
much.
very much.
Thank you.
Our session's last presentation is real-time on-the-go annotation framework using YOLO for automated dataset generation. This presentation will be made by Mohammed Salam. Do we have this presentation somewhere here? Yeah, just briefly introduce yourself to the audience and then you can start.
So good morning everybody, my name is Mohammed Salim. I'm from Northwest University. I'm a PhD student in Urban Agricultural System Engineering. So today I will be introducing a real-time on-the-go data annotation system. It's an automated framework for doing data generation in general. Can you use the presenter?
Sure.
That one is not there.
The red color is the.
Oh.
Yes.
First of all, as a brief introduction for our work, we all know that it's very important to have a very well annotated and labeled data set, like this data set. This is kind of labeling or polygon drawing on any one species data set. Usually, you might have classification model like VGG16 or any other classification model. In that case, you have to sort your data set in a specific order, or you would have to train a YOLO model or any object detection model. In that case, you have to do manual annotation or manual labeling for your data set by drawing a bounding box, or even like segmentation like this one, drawing a polygon on the data set. So the problem here is this is very long process. It's very like if you have ever trained any deep learning model, especially from scratch, you would have spent a lot of time in this process. It's like a bottleneck, and we just need to automate this process. Especially in agriculture, in our idea actually, we usually go to the field, run or deploy any robot or something, and then trying to capture some data, going to the lab, spend too much time annotating this data set. So this is like a bottleneck. We have to manually do this process. We have to store the data in specific order if we'll do classification or if we'll do object detection or segmentation. So even if you finished everything this year and you are interested next year to include one more species like new weed or new plant, you have to arrange the data set. It's very hard to scalable this data set. It's very hard in scalability as well, especially if you do or if you did the manual annotation process. So simply our framework is very simple approach. Instead of doing that, we need to do it in the go. So we will train a deep learning model. That model will be doing the annotation on the go. So this model will be deployed on UGV or any ground vehicle or even a drone. And that robot will be trained to identify where is the plant. And then based on the plants here, this model will be deployed to the robot, and the robot will be going to the field, just finding the plant drawing the object detection or the segment the speeches, and then afterwards we can train that model. We can easily doing that kind of segment labeling by prompting that approach, like just writing, oh, okay, this is like weed, this is plant, this is something different. We can even do that on the go. So we can just by talking with the robot, this is weed, this is plant, this is weed and this plant, on the go, while the robot is like just working and collecting the data. So before going and diving deeper inside our methodology, first of all, let's just emphasize that real-time annotation is not also easy. It's not easy to deploy a deep learning model. Sometimes you have to wait very long time just to launch to boot the model. The model takes like 30 minutes just to be able to start the annotation process. Also, like in the field, processing is not easy because like sometimes you get some like correlation or intercropping species. So in that case, it will be also not easy. So what we have done in order to do it in the fly. So let's talk about the traditional framework, what people do these days, and then we will go through our framework. So usually if we have a robot deployed to a field, that robot will be seeing like this kind of scene. There are like some species like plants and weeds. And then we usually, these days, we go to the field, we just capture images, we store these images in a specific order, and then we spend too much time on the lab using RoboFlow or any other kind of annotation processes to annotate this data set. So this process is very long and takes time, and it's really, really time consuming. Our proposed approach is very simple. If we have the same thing, the same setup, we have the same robot, we deploy that robot, but just the camera that will be capturing the image will be also doing the inference or performing the inference on the go in that robot, and then the robot will be capturing the image and storing the bounding boxes along with the image. So we'll have the annotated data set on the go. We don't have to go to the lab and do this kind of annotation. The only problem here is like we need a very well-trained model, like general trained model. Or since we are doing this in agriculture, we can just train the model to identify the plant. Just know where is the plant, give me the bounding box to that plant, and maybe even after that I can go to the lab and easily I can just change the number, like it's just from 0 to 1 or from 1 to 3 and so on. So, or even we can do that on the go as well. We can do that by just prompting the robot, like saying like this is plant, this is weed, and so on. So after that, we will store the data set on our local storage in the robot, and then we can train any other deep learning model by distinction between the bounding boxes. So first of all, in order to do that, we have to analyze some kind of different models. We have to know what's the faster one. We have to know how to train these models in order to be deployed and working on the go in real time in the robot. So before going to the methodology, simply always, if you want to train a YOLO model or any kind of deep learning model like pre-trained, sometimes you will find some benchmarking data set like Coco data set. If you will be using the YOLO model that's trained on Coco data set, this model called pre-trained model. Also, we can do something like very similar to RoboFlow. So in RoboFlow, if you are using RoboFlow to annotate your data set, you will know that they also have auto labeling process. And this process, like they rely on pre-trained models. These models trained on many different classes with many different labels. So we also need to know, like, if we trained a model on multi-classes, a lot of different classes, or if we just focused on something like plant, just one class, what would be also the difference between training a deep learning model or especially these 3 YOLO models on pre-trained data set, so starting from already pre-trained weights, or starting from scratch. Also training these models on just one single class or multi-classes. And we have 3 different YOLO models. So in that case, we will go to the framework, but in that case, we will have 12 different configurations. I'll give you an idea about these 12 different configurations. But before going to that, let's talk about the related work. Is there any like something similar to that work? So as I mentioned, actually RoboFlow, they have their own auto annotation process. So you can go to the RoboFlow. However, this is not on the go. This is not real time. Still, you have to collect the data. You have to go to the lab. You have to upload this data to RoboFlow, and it's going to be open source. Especially if you are doing like credential work or something, you cannot make it open source. It's not going to be the best option for you. Also, there are models like general trained. So if you are doing very specific tasks, it's not going to be accurate. There's something similar to RoboFlow also called Encode. You can also do some kind of auto annotation, but still it's cloud-based. It's not real time. You cannot deploy these models on the go in your robot. Another similar approach published in IEEE transactions. This is really interesting approach. It's called Open Annotate 2. This picture from their work actually, and they like simplified the 3 different approaches from the related work. So usually in the regular work we go annotate manually, and this is like the process I mentioned before. This is very long process. They also did something called Open Annotate 1 before Open Annotate 2. That was based on large language model. They prompted the large language model to do the automated annotation process. So they just say, okay, we need to do bounding boxes on the humans, like like any species in the picture, just annotating this process. But in that case, you have to spend too much time to do this kind of annotation. And for every single image, you have to prompt that large language model in order to do the annotation, but still also not the best option. They also developed that option to do just one prompt to annotate the entire data set. But I have to mention that this is also not real-time process. It's not going to be accurate. You have to make sure that, because like this kind of large language model is general purpose model. It's not trained on your data set. So if you are doing very specific tasks, it's not going to be the best option or the accurate option for you. So before talking about the 12 different configurations of YOLO models and the accuracy of this kind of real-time annotation process, we have used and utilized a dataset called weight crop dataset. This dataset is also published by a team from NDSU. This year, 2025, it has 13 different classes. 8 of these 13 different classes are crops, and the rest, like 5 classes are weeds. So since we usually are interested in weeds, I just mentioned the weeds types, but the main purpose here is we have always 2 options. We can train the model to identify what's the plant, if we are like working on soybean field, and then once the robot is just having an idea where is the plant, we can just avoid that plant and control or kill the other species other than the plant. So this is why I'm discussing. We can just train one class, and what's the accuracy of training the model on just one class. So simply, I just made all of these classes just one class. So I went through their files. I changed the classes from 0, 1, 2, 3 all the way until 12 to just 0. And I had one class. I tested that on YOLO models. I used the same configuration, 13 different classes. So we are testing multi-class, single class, pre-trained, and scratch on 3 different YOLO models. So that gave us 12 different configurations. We have used YOLO V5, YOLO V8, and YOLO V12, 12 different configurations of scratch, pre-trained, single, and multi-class. And then we deployed it on UGV or unmanned ground vehicle, Omega platform, and we tested in real time to see that bounding boxes and see if really that approach and framework can give us a data set, like real data set in real time. So those are the 12 different configurations of YOLO models. As I said, we have a YOLO model, let's say YOLO V5. We will train YOLO V5 on single class, just to identify where is the plant from scratch without any pre-trained weights. Also, we will train it on pre-trained weights like COCO dataset. So YOLO V5 will be trained from scratch, single class. From scratch, multi-class, pre-trained single class, pre-trained multi-class. So this is just for YOLO V5. Multiplied by 3, we will give the 12 different configurations. So we need to know which one will be performing better in terms of not just accuracy, also the inference type. Because we are interested to deploy these models on the go. So the robot has to use these models to identify the plants in the go while the robot is working in the field. So as we can see from the accuracy, actually mostly the scratch and the model, so the pre-trained models that has scratch class or single class. So we have S and M. S is the scratch and M. Scratch and M is the multi-class. We have also S and P. S is the single class and so P is the pre-trained, S is the scratch, and the multi-class is the M, and single class is the M, S. So this is the box plot of the 12 different configurations training on the mean average precision. We are interested to know if the multi-class pre-trained will be performing better than the single class pre-trained, or the scratch pre-trained will be performing better than the multi-class pre-trained. So as you can see here, like you can see like this 12, 5, and 8. 12 is the YOLO V12, 5 is the YOLO V5, and 8 is the YOLO V8. And we have the MP, which is the multi-class pre-trained, and MC is the multi-class scratch, and SP is the, multi-class, MP is the multi-class pre-trained, MS is the multi-class scratch, and SP is the single-class pre-trained, and SS is the single-class scratch. So, since any model like YOLO V8 or YOLO V12 could be trained on very public dataset, like with significant amount of classes like COCO dataset, if we use that model to start the training process from the same weights as it achieved based on COCO dataset, it will be performing better than the scratch. So when we take a look at the YOLO V8 scratch here, we will see the spread. So the model was like performing usually better, like in most of the tested images, with the scratch configuration, with the single class configuration pre-trained. Also even like YOLO V5 and YOLO V12 with the single class pre-trained. So we ran a statistical analysis and validation based on t-tests, and as you can see, and we were able to find a significant difference between the pre-trained and the single class, and also between the pre-trained and scratch, and between the single class and multi-class. But before just judging based on just the accuracy, we also are interested to know, is there any difference or significant difference between the inference time between the three models or not? So when we have tried the inference time between the three models, pre-trained single class, we found that the YOLO V8 was performing better in terms of the inference time. It's very fast and like compared to the other models, especially like YOLO V12 has transformers and a lot of like complex configurations inside, so this takes time to just performing the inference in real time. So most of the models actually achieved like inference in less than 500 milliseconds in real time, but based on the configurations and based on the accuracy, we will deploy YOLO V8 by then eventually. So we have tried that in real time, like the inference on Amiga platform. We tested that model on, since the dataset has 13 different classes, we tested that model on one of the classes. And then we've tried it on another species which does not exist actually in the dataset. And also the model was able to achieve a performance like confidence score, like prediction confidence score 83%. Also we've tested the the real-time inference also in very complex environment. Like usually the data set would have a weed or plant with soil, like regular soil, but we have tested it on like concrete and also with shadow, and the model was also able to achieve almost 80% accuracy of detection. Also, this picture has been saved in a folder along with a text file, YML file that has the annotation or the bounding boxes, the location of the weed and everything. Key insights from our work: we have tested the pre-trained and scratch. We came out like that the pre-trained is performing better when it comes to training from scratch. We also have tested the single class and multi-class. Single class performing better because like you will not have to take too much time to train the model just to be able to identify the differences between the plants, especially like in something like plants, they are so similar at some point. Multi-class also needs some kind of training from scratch. YOLO V8 performing better, and in terms of the speed and the accuracy. In conclusion, we can use data annotation in real time. Just that was the main purpose of that work. That actually making the annotation process or data generation process faster than the regular annotation process, especially the manual processes. We can use that in real time in the field. For the future work, we are working now to just prompting the robot like based on voice guided annotation, just saying like this is like weed and this is plant. We are also testing different configurations of edge devices and single board computers along with accelerators. And we have tried multiple data generation points by doing some different cameras and seeing like if the robot can do that in real time. Thank you so much for listening. We have to acknowledge USDA to fund that work, and also North Dakota State University and everybody here from North Dakota. Thank you so much. Thank you for listening to my presentation.
You can go.
Yeah.
Yeah, a lot of confusion, single, scratch.
Yeah,
things.
sorry.
What do you mean by scratch?
So scratch is just training the model from scratch, like YML model. Like I'm taking YOLO model with just the architecture of YOLO model and starting the weights by randomly initializing these weights.
Okay, so it's the YOLO model that uses
Yeah, the YML,
scratch.
not the PT. Yeah.
I mean, then isn't it obvious that pre-trained should perform significantly better?
Yeah.
So for, did you do cross-validation for your results?
I did cross-validation based on the epochs, the learning rate, and also the dataset itself. I've split the dataset into different splitting ratios. Like so, we had test and validation and the training, and then we tried 10%, 20, and 70, and then we have tried 20, 30, and then the rest. And yeah, we have tried 3 different configurations also of the data splitting. So that was the validation based on the ratio, the splitting ratio of the data, the learning rate, and the epochs, the total number of epochs.
So that also.
But that was like very intensive because we have 12 different configurations. If you multiply it by 3 different configurations, I wouldn't be able to introduce that here.
Yes,
So I'm
yes,
just keeping that for the extended version of the paper.
I guess you use CCast resources, maybe.
Yeah, of course. Well, we have also like a workstation in our lab.
Okay, that's
it's very powerful. Like it has 4 GPUs, and yeah, I can train these models easily. I've used it in the local workstation.
Cool.
Okay, so actually we can get one more question, or we are short in time because it's the coffee break time. So actually we can discuss maybe the extra questions in coffee break. Okay. So thank you very much. Again. So please. Okay. Thank you very much. So that's coffee break time now. So,
Sorry for the confusion.
That's the second one.
Good job.
I was planning to take graph neural network this semester.
You couldn't make it.
Yeah, I just realized when I was registering actually that there's conflict between the same time of the class and the other class.
That's unfortunate.
Yeah, probably like, maybe next year I will try to join the neural network course.
Yeah, hopefully. Yeah. You did YOLO also, yeah.
Yeah.
There was one student from your department, I guess,
Manuel?
in neural network.
Manuel.
Yeah,
Steve.
Manuel, yeah.
Yeah.
He mentioned maybe.
Yeah.
He was good actually.
He
was very
encouraged me
interesting.
actually to register, like even
Actually,
in the
graph.
graph.
Yeah.
And he also encouraged Ajay, like he's doing that class this semester. He's Indian.
Oh yeah, he's yeah. Yeah, I'm glad. Yeah, nice to meet you. I haven't seen you before.
Yeah, thank you.
Everyone is.
So let's see.
Yeah. I was actually.